Hi and welcome back to this tutorial series on Postgresql clustering. And in the last video, I apologize, it was quite long, it was an hour and a half. We covered Barman and the configuration of the backup and recovery manager, which is what Barman stands for, in order to do two jobs really: to take backups, regular backups of our primary database, and then secondly to store logs as they're generated by the primary, so that they also form part of a part-in-time recovery if you need that. But the good thing about Barman is we can also use it when we're setting up a replica. So I don't know how often you've thought of this, but if you want a secondary of your main primary database, then you're going to have to effectively copy all of that data across to your new server. And when we're playing around on our little test systems like we have here, we might not think about that too much. But imagine that your primary database is, 500 gig or a terabyte or 5 terabytes. Even if you're within a data center and you have, super high speed network, it's going to take a very long time to copy that data across. But more than that, you're also then imposing on the primary server's disk to actually retrieve all of that data for you, just to copy it across. So one of the really cool things about using Barman when we talk about replication is that we can take the data from the Barman logs and backups directly to our replica, and then only at that point do we then copy the remainder of the logs from the primary, any ones that we don't currently have. And just with that small amount of work that the primary does, then our replica is ready to go really quite quickly. But Barman itself doesn't actually have that functionality. All Barman is really doing is storing those files, those backups. So this is where Repmgr comes in. Now, like Barman, this is not part of the Postgresql core functionality, which is a shame because it's a nice little utility. It's just another third-party application. It's managed by Enterprise DB, who are one of the main sponsors behind PostgreSQL anyway. And when it comes to sort of replication and failover, back in the day, we talked in the last video about Postgres having a number of sort of archiving tools, which were quite kind of clunky. You generated a file, you copied the file using, rsync or something like that. And then you would have to then copy those files over to your replica. You'd have to run another command to set up the replica. And then, of course, failover is actually quite a complicated thing. We think of it just as switching over from one primary, to a different primary. But of course, a number of different things have to happen there. We have to stop the primary from accepting any new data, so that has to go down in some way. We then have to take backups or logs to get the latest data. We take a checkpoint, we take the logs off of that primary over to the secondary. We make sure that they're applied automatically to the secondary so that the secondary is up to date, because we don't want to fail over to an older version of the timeline and lose data. Ideally, we don't want to do that. We then have to promote that secondary to become the new primary, and then we have to tell all of the other replicas to stop following the old primary and to start following the new one. Now, if you were doing that manually, of course, there would be lots of different things to do on a number of different servers. Our example, we have 3 database servers, but you could have 50 for all I know. You're not going to be logging into 50 separate servers and running the same commands on all of them to say, oh, you need to replicate now from a different database. And although you could set up your own tooling, it's all a little bit of a faff. The nice thing about Repmgr is what they've done is they've designed a command line interface to wrap all of that functionality, and literally just in one place on one server you can run a command which will coordinate all of those activities. It will stop the old database server, it will do a checkpoint, it will copy the logs, it will bring the new one up to date, it will promote it, it will tell the other ones to follow. And in our production system, which isn't very big, I think it's about 5 gig database, it takes maybe 3 or 4 seconds for that whole process to take place, obviously assuming that there isn't a lot of traffic coming in at the time. So I've usually done it sort of late at night, so it can all happen really quickly, but that's because of the automation that you get with Repmgr. And the 2 main commands that you're really going to see There are a number of them if you go to the Repmgr docs, which are quite easy to find on the internet. Standby clone is how we create a replica. So that's the one that can go to Barman, say, give me all of this data, please. I'm going to effectively restore it onto the replica, and then I'm going to sort of start it up and running. So that's that side of it. And then the Repmgr standby switchover is the command that you use when you actually perform a failover. There are a number of other options. We're not going to talk about automatic failover. It is possible, but personally I find in most scenarios you probably don't want it to happen automatically, because usually there's a danger of at least some data loss. So you kind of want to know when it needs to happen, in my opinion, and you normally need to do it manually. But you can set up Repmgr daemon to run as part of the Repmgr installation, and you can get that to keep an eye on things and fail over. But like I say, with the way that our production system set up, I've kind of avoided that. There are a number of other things that we'll see as we go along. So there's like the register command, which is effectively adding the information for the Postgres server into the Repmgr database. So we'll see all of that happening as well. And hopefully this won't be as long a video. I will be editing this one because I suspect there's going to be a lot of repetition, setting up SSH keys and all the rest of it. I'll show you kind of one example of how we do it, and then I'll kind of leave it with you guys to kind of go and repeat that on all of the other machines. Because if you remember that in most cases we need to make sure that the postgres.conf, the pghba.conf and the repmgr.confs all need to be almost identical across all of the machines. The Repmgr is slightly different because it has obviously host names in there, so the one on host 1 is not going to be the same as the one on host 2, but we'll see that in a bit. But yeah, it's pretty straightforward to run once it's installed. Now, in terms of installing it, I've already done this on my Vagrant boxes. So Postgresql, now there are different versions of Repmgr to work with the different versions of Postgres, and you can install them alongside each other. They get installed into separate version directories, but in most cases you're probably likely only to have one version on at a time, so you need to make sure you install the correct version of it. And the other thing that you're going to need is Barman-CLI, which are some of the utilities that Barman uses in order for Repmgr to go talk to Barman and say, get me all of the archive files that I need and send them to me. So you need to install both of those, but that's kind of dead easy. Now, one thing that won't happen, interestingly, is when you install Repmgr, you don't get a configuration file by default. So it doesn't create you an empty one, and I guess that's probably because all of the settings in there you're going to need to set to suit your infrastructure. So there's probably not an easy way for them to give you a default one, because it wouldn't work at all. So we have to create that. The other thing to know is that some of the help documents that you see will pass in the configuration file using -f. So you can do repmgr -f and then point to a configuration. So again, that allows you to have multiple configurations if that's what you need. But by default, it will look in /etc directory. So we're going to create a /etc/repmgr.conf file, and that will automatically be looked in. And the reason that's handy is it just means we don't have to do -f all the time, because that gets a bit boring after a while. So that's basically what we're going to do, and we'll use a kind of a skeleton one to do that. So we're going to look at the configuration file in a minute. I've got, like I said, I've got a copy that we'll paste into our different Postgres servers, and there are a number of these sort of parameters which I'll talk through once we have done that. So just to remind you, at the end of the last video we had Barman up and running, so that's taking backups of Postgres 1. Postgres 1 is up and running. It has a database on it that we created. It's called like test or something, I suppose. And we have two database servers which are running, but they're not replicas, so they don't have any databases on. They would just have the default main cluster that you get when you install Postgres. So these are the two that we're going to be setting up, but we want to set up that Repmgr on all of them. So I've got them all open here in separate windows using Vagrant SSH. So I'm SSH'd into these different places. Now Barman doesn't need a rep manager config, so I'm not going to worry about that for now. So if we go onto our Postgres 1 server and we're going to do sudo nano, this is the location that will be looked in by default. So we're going to do that. I'm going to copy in an example of a rep manager config file that I've copied off of our production system. So this is just an ID number, so they just have to be different on all the machines. I mean, I could do this all at the same time, I guess. The reason I'm doing this as the Vagrant user is because Vagrant user has sudo privileges, whereas the Postgres user, which is what's actually going to run rep manager, doesn't. So I just have to do that. So sudo c repmanager.conf. Just did that again. No. Right, so as you can see here, well, node 3, 2, 1. So you can see here it's going to be a lot of kind of noddy work. So I won't do it all at the same time. I'll cut the video in a little bit. The host name, it needs to be the host name. It can't be localhost, and the reason is quite simply that if this runs on another server but needs to talk to Postgres 1, then if it said localhost, it would talk to its localhost and not to Postgres 1. So we need to make sure we use the name of the machine there. Now this is something where we need to just be careful, because if I just exit one of these, we need to make sure that all of these directories are correct. Now this directory here won't be correct because our production system has a separate disk mounted on /SQL data. I think I should have checked this out, but varlib Postgresql 13 main. Ooh, it's not going to let me do that. That's all of the data for the data directory. So that's actually the path that I need here. So I can just go back to here and change that to varlib. Make sure I did it correctly. 13 main. So that should be correct. The IP of the Barman server, now we've called ours Barman 1, so that's handy, that's already correct. Now this is a bit where we've got to be careful, because this is where it can be quite confusing. This comment that you get with the file, the example file, says the backup name of the current database. So it's not, we're on Postgres 1, but the important thing here is the backup that we currently use is also called Postgres 1, because this is the primary. How do we know that? Well, if we do Barman, I don't actually know how you can do list all of them, but did that last time, didn't I? So it's called Postgres 1, so that's the name there. Now obviously we're not going to be running this against Postgres 1 because Postgres 1 is currently the primary. So at some point what would happen is if we, let's say, failed over to Postgres 2, we would then have to set up a Postgres 2 backup to run in parallel, because then that would be moving forwards and the Postgres 1 wouldn't, because it's not going to be the primary anymore. And then we'd have to go around all of these files and change them to point to Postgres 2 instead before we fail back. But I'll leave that to you to worry about. Now the restore command, this is one of the programs that you get when you run Barman, when you install Barman CLI. So if we just check again, it's these sorts of things that if you don't check, you might end up coming unstuck when you try and do a failover, because that's going to call Barman while restore, and you can see that there is a Barman while restore, so that's fine. But if it was in a different directory on Debian, because this is from an Ubuntu machine, then what's going to happen? Goodness knows. You're going to try and restore something. At best, it's not going to work, but at worst, it might screw something up as well. So we've got to be careful there. Now, the user that is going to be running on the Barman server is Barman, so that's fine. The server is Barman 1, and the name of the backup is Postgres 1. So those things are all going to be correct already. And now this is another one where you've got to be careful with the bin directory of Postgres. So again, let's just double check here. User lib Postgres 13 bin and lib. Yep, so that's correct already. And there is actually, the log file's fine, replication slots is fine. There is a bug in the Repmgr package, and I can't remember exactly what it is, but basically, even though that directory is correct, when it tries to run pg control in order to stop and start things, pg control gets confused because of a bug in the code for Repmgr. So in order to work around that, you need to make sure that these service commands are correct. And again, we can test them just by copying that, and if I run it here and just see, that seems to work fine. So the rest of them are obviously the same, they just have start, stop, restart and reload. So we need to set all of those as well. What happens when you try and do that otherwise is, again, it all seems fine, it all runs fine, but as soon as you then try and do a failover, part of it doesn't work. If it's the part right at the beginning where the primary won't shut down properly, then it's safe, as in nothing's going to break, because it will eventually time out waiting for the primary to stop, but it won't fail over, and then you'll be stuck. And if this is an emergency failover, you do not want to get stuck trying to work out what's what. So I will cut the video at this point. I'll fast forward till after I've done these other two, and then we'll talk through some of those parameters again. Okay, back again. Now, when we talked about Barman earlier, we said that depending on which mechanism you're using for backups, if you're using archiving, then you have to set up SSH between Barman and the servers, and between the servers and Barman as well. But we didn't need to do that for the replication with the well shipping using the replication slots. But we do need SSH for Repmgr, and there are two reasons for that. Repmgr needs to be able to talk to Barman in order to say, send me all of your stuff please, and it needs to run that over SSH against the Barman server. And in the other direction, Repmgr needs to speak with all of the other servers. So if I run a failover on this machine needs to SSH to this machine to tell it to change in some way, whether that's to shut down or to promote it or to start following a different replica. So all of those connections are done over SSH, and obviously the only way you're going to automate that is by using SSH keys, and we can use the ED25519 format to get a nice short key. Now I'm assuming that most of you kind of have experience of doing this, but I just want to very briefly make sure that we don't kind of screw anything up. So we need to remember that it's Postgres is the user that runs the database, and is also going to be the user that we run Repmgr from. So this is the place where we want to create the keys, and it's much easier for you to go into an interactive prompt using sudo to just avoid sudo -u blah every time you want to run something. And it'll be the same on Barman. I'm logged in already as Barman. Now if I just list okay, there is no SSH directory in there, which means there's no key yet. And if I do the same here, there's no SSH in here, so I haven't set any of this up. But basically we'll kind of do the same thing and then have to go into lots of different files and put all of the keys everywhere else. So each machine is going to have its own key, so we'll just use the SSH keygen -type ED25519. Now you can always accept the default for what we're doing, that's fine. We can't have a passphrase because this is going to be for machine to machine. And if you look at the SSH directory, we now have a public key and a private key, which is what we'd expect, and we'll run this on all of the other machines later, and I'll fast forward again. So once we've got that, we then need to go to the machine that we need to connect to, and in this case it's the barman machine, but it's also the barman user. And then it's probably easiest for us to actually do the key gen here first, and the reason why I'll show you in a second is ed25519. We're going to do that, and the reason is when you look at the SSH directory, you can see that it gives it special permissions. So it's 700 if you like numbers, or you know, RWX whatever, for the owner. So no one else is allowed into the SSH folder apart from barman. Now the reason I've done that is it saves me creating the SSH folder for the authorized keys file, which is the file that we create to say who we trust to log into this machine as barman. So I can just create one of those now with nano, but without having to change the so it's basically that command. We nano a file like that, and then what we have to do is you have to get the public key from here, and it's called id underscore, and we want the .pub1. So all we then do is we copy that and we put it in here. We're going to obviously repeat this for Postgres 2 and Postgres 3, and notice that by using host names is that automatically the SSH keygen has picked that up, and that just gives you a nice little handy label. When you have lots of database servers running in a cluster, at one point, let's say you delete server 8, well, you can go into this file and quite easily find which line belongs to Postgres 8 and delete it if it's no longer needed. So they're quite handy little things there, but you can see that it's the Postgres user at Postgres 1, and because it's in barman's authorized keys file, it means that what should happen now is if I do, and again I'll just do this once, but if I do SSH barman at barman 1, first time you do it, and you do need to do it manually the first time, this is really important, it gives you that age old, are you sure you trust it? Now if you're more paranoid than me, you might want to do other things to check the fingerprint of the key on here, but I'll just say yes for now. So now that's been added, you can see now that I'm actually logged into this server from Postgres 1. So you need to remember it, you don't just set up the keys, but you need to actually connect in each, you know, each connection in each direction. You need to make sure that you connect the first time just to do that. Otherwise, when the machine's trying to do it, it will just fail and it won't connect. So I've done that for one example. As I say, I'm going to repeat exactly the same thing. I'm going to put a key in here and a key in here, and then basically be swapping all of the different keys into the different authorized keys files. So Repmgr can basically talk to barman and talk to the other servers. And the other thing that I just want to check, because I can't remember if I've done it, is in here it's automatically added that line for the current server, and it seems like I do have some kind of DNS, because when I SSH'd into barman 1 it was able to find that, but it probably makes more sense, although I'm going to have to go back out into here again because I need to sudo done it again, sudo nano etc. Blame my desk. And in here I'm going to also add Postgres 2, Postgres 3, barman 1. Again, you've got to be thinking of all the things that could go wrong. I don't know how that DNS is working. It's probably something to do with a virtual host, VirtualBox network. But I don't want that to break while I'm trying to do a failover, and then the failover doesn't work because it doesn't know where Postgres 2 or Postgres 3 is. So I'm also going to get the IP addresses of those, put those in here, repeat that for the other machines, and again, I'll see you back here on the other side. Okay, we're back, and we have all of the SSH keys set up across all of the servers, so I can SSH from any of these database servers to any of the other database servers, and from all of them to barman as well, and that's all been tested as far as I remember. So SSH barman at barman 1, and that works fine. So that's all done. The next thing that we need to do is we need to create our users for Repmgr to use the database in order to keep track of what the cluster is currently doing. It's kind of just a couple of tables. It doesn't really have that much in it, but it just helps Repmanager to know through replication what is going on with the cluster at any one point in time. So obviously if you make a change to the Repmanager database on the primary, then that gets replicated across all of the others as well. But obviously if you then run Repmanager from a secondary, it has to go talk to the primary in order to update the table on the primary in order for that table to get copied across, but it kind of does all of that automatically. Now at the moment, remember, I don't have anything really set up on server 2 and server 3 at the minute, just have it on server 1. And because I'm logged in as Postgres, I don't need to use the sort of sudo -u stuff. I can just do psql, run a command. And what I'm actually going to do here is I'm not going to bother using a password for this, and that's just because I don't need to. I will lock it down using other different sorts of rules. Now, why am I doing these things in capitals? It doesn't make any difference. No, but it just makes it a little bit easier to read. So I've created a user, and that is a replication user. So that's the bit that's going to set up all of the slots in order to set up our replicas. So it's pretty cool. And then the other thing that I need to do is create a database. It's going to be called Repmanager as well, and the owner is the Repmanager user that we just created. So again, hopefully that works as well. So that's fairly straightforward. Now what we need to do is we need to add a load of rules into pghbaconf, the access control file. And if you remember where that is, it's under here in Debian Ubuntu, pghbaconf. And because I'm logged in as Postgres, I don't need to do any sudo or anything like that, but let's just run that on these as well. Now we've done some stuff on the one on here because we set up Barman, and if you notice, we've already fallen behind because, as I mentioned earlier, if we do failover to make server 2 the primary, then we're going to need Barman to start backing up this, just because it will have the data slightly ahead of the other replicas, but it also allows you to reboot the replicas quite easily if the backup is coming off of the main primary server, because obviously primary has to stay up in order to work. So first thing I'm going to do is we'll just copy all of these across as well. So let's just try and make these look at least roughly the same, and that's in there. So we'll just double check it. That's the Barman server 171, so that's all should be correct. It doesn't matter at the minute whether these things exist on the server, because they won't at the moment, but that's fine. 56.1, 56.1. So yeah, I'm not actually sure whether that will work. Oh yeah, I think it should be fine. It's this confusing thing about the fact that Vagrant creates multiple networks, and it's quite hard understanding networks on VirtualBox plus Vagrant. It gets a bit confusing, but anyway, that's all we need in terms of copying the Barman entries across. Now I'm just going to copy these in from my PowerPoint, which is over on the other screen, and we'll tidy them up once we get here. Right, so we kind of have two groups really. You can see here, let's just tab these in a bit. Don't know why it doesn't like spaces and things. So we'll get that, do that. So we have the replication connection. So this is a special one. I think I mentioned this in the last video. This is a special database name because there isn't a database called replication. What it basically says is you're allowed to replicate any database, but it doesn't give you normal access to those databases. It's just for replication. So we need entries for that, but then we also need the normal entries, which allow our Repmanager user to access the Repmanager database in a normal way, so it can read it and write it and all the rest of it. Now what we're saying here is if Repmanager, it's annoying little red boxes, if Repmanager is running locally, then we can trust it, whereas if it's coming from another subnet, now remember the Repmanager can be running on any of these other servers, so you might want to lock it down more than this, but for now I'm going to just do the entire subnet of 192.168.1.0 because that's what our machines are running on. And then this one is a special one for localhost, which again I can't quite remember why, but you do need all three of them, even though you'd think that, I think because local it only uses a Unix pipe. So if you're running locally from the command line, I think it will use a local one. But if you're running over SSH from another machine, it actually comes in on IP, so it will hit localhost address, something like that. But yeah, it's basically what we've got to do there. And then in some ways a very similar kind of idea for the replication connections as well. 192.168.1.0/24. Remember to use a CIDR, or some people possibly call it CIDR, I don't know. But yeah, even if it's a single IP address, it has to have the subnet at the end of it, otherwise it won't work. So now that I've done those, all I've got to do is copy them exactly the same into here. And you can see here the real benefit of having a system where everything can be identical. So you could pretty much clone one of these servers at a hardware level once they're set up, and it would all just work. You don't have to like put different IP addresses in here than you do in that one and do on that one, because that would be a real pain to try and manage. But by using subnets, then this works. You can have more than one rule. If you've got, let's say, 3 IP addresses and you don't want to put the whole subnet, you can just put 3 rules individually with a /32 on them if you want to. That's up to you, but just remind you again that the rules evaluate from top to bottom. So if you're having a problem with something not connecting properly, there's a very good chance that an earlier rule has matched the connection, and therefore it is being used to decide whether you get in or not. Remember, it doesn't evaluate all of the rules. It goes down until it finds a match based on these first 4 columns, and as soon as it finds a match, that's the rule that it uses in order to decide then whether it's going to require a password, MD5, whether it's just going to let you in or not. So that's all done. Now normally we would do a reload on the service in order to reread that in, but we actually haven't done all of the rest of the work yet. So let's next look at postgresql.conf. So if we go back to here, because it's in the same directory, and we do postgresql.conf, and again we'll do exactly the same thing on these other ones as well. If we look for the word preload, so Control W, where is, do the same here, preload. You'll see it's commented out normally, this line here, shared preload libraries. We need to make sure the Repmgr gets loaded, and that's because it has the ability to create the database that it needs and all the rest of it like that. As it often does, it tells you here that if you change this parameter, you need to restart PostgreSQL, which is fine. We'll do that in a second. So we'll do exactly the same here, shared preload libraries. And because we've already installed the Repmgr apt package as part of Vagrant, we don't need to do anything else to get that library. We just need to make sure that it's loaded. I'll say as if it's just going to magically work. And to reload the service, we're going to have to go back out to our sudo service PostgreSQL. Now there is a syntax where you can specify the version of it if you're running multiple versions, but actually you can still use the generic PostgreSQL restart if you want, and that will still work. But if you did have, let's say, version 13 and version 14, I don't know whether that would restart both of them or whether it would restart neither of them. But yeah, in our case we've only got one version, so we can just run PostgreSQL restart. We saw in Repmgr actually what the syntax looks like if you want to specify the version, so you can kind of go and look in that as well. Okay, so user bin Repmgr is the sort of location of that file. You can obviously, oops, I accidentally pasted it in again. You can obviously add it to your path and all that kind of stuff if you want to, but hopefully, if I've done everything correct, I should be able to do this. Connected to primary, attempting to install. Repmgr is not a super user. Okay, so what I will need to do, how can I do this? I can either make, in fact I think Repmgr does need to be a super user, because it has to be able to do things like checkpointing and stuff like that. So I think, I don't know why the instructions didn't say that, but if we just do alter role Repmgr with super user. Okay, I don't know if I need to do that. I shouldn't need to do that on the other ones, I don't think. So now I've done that, what happens if I do that? Okay, so info connected to primary database, that's obviously my local machine. Attempting to install extension, which it's done. Extension successfully installed. Primary node record registered. Now, even though I've only added one thing at the minute, I should have cluster information. So all of a sudden, Repmgr now finds itself without the path. So maybe running that also adds the thing to the path. I don't know. Repmgr cluster show. Again, this is probably not reading quite well because of that. So let's just do that again. So the name of the node, Postgres1, its role, the little star to say it's running, location, priority, timeline, and connection string. Now what's going to happen is as we add the other replicas, we can then call this from any of the other servers, and it will also then show line 1, line 2, line 3. So that's the ID we put in repmgr.conf. Obviously you can give them different IDs, but I guess it makes sense to use one for Postgres1 and stuff like that. So that's nice that that bit is basically working. And then we're going to basically run through how we actually set up a replica, which again is kind of pretty straightforward, assuming this all works properly. So this is the order that we do stuff here. So first thing we do is we stop Postgres from running. Why is that? Well, we're basically restoring a database to all intents and purposes, and you don't really want to be restoring a database into a file system that's in use. That's pretty much what we do there. And then we have a really horrible, well, let's log in as Postgres because that will save us typing half of this nonsense. So first thing we're just going to check is no command provided. Oh, so it did work. I thought that error meant that it couldn't find the executable, but it could. So we are going to run Repmgr. Now the host is our current host, Postgres2. We possibly don't need that, but let's just say we will read it. We will do it. This is the Postgres user, the user that we want to connect to the database with a capital U. We're going to then use the Repmgr database because that's what's relevant as well. -P for the port number. I don't think we need that because it should default correctly. -F for force. Standby clone, and we're going to add this tag dry run. Oh, sorry, I was trying to use my arrow keys. Super useful little parameter. It will run through as much of the process as it can, and it will tell you if it looks like it's going to succeed. So all we're really doing here is saying do this to the current host. Now obviously if we had SSH set up, we could potentially run Postgres3's command from here, but I'd rather not try that. Using the user Repmgr and the database Repmgr, the -F just means force it, which might or might not be needed, but there's no harm in doing it because this is a brand new clone. And then really these are the two key words here: Repmgr, standby, clone, in this case do a dry run. Now if you run that, remember that we've got a repmgr.conf file, so that's how it knows that it can go and use Barman and everything else. So we can see here that it's found some various stuff, so it seems happy enough with Barman. Connection string Postgres2, so that kind of seems okay. Connection database failed. Detail could not connect to the server. Connection refused. Is the server running? Now I'm just wondering whether I should have actually connected to Postgres1, which is the one that is actually running. So maybe I put that command in wrong. Well, let's try that. It's just a dry run. Okay, so this is much better. Let's just clear that and run it again. So like I say, it's testing the connection to the Barman server. So the repmanager.conf says that we can use Barman, so it's tested that. Found a valid backup, so that's all good. If there wasn't, again, you get an error saying there aren't any backups, so I'm not going to be able to do this. Got a connection string to the primary. Current installation size 40 meg. Obviously we haven't got much in our database. The extension is installed, so that's good. Target directory appears valid. Will be overwritten. Now it's really important that you remember that if you're playing around with this on a system that's already running or one that's in an unknown state, you might want to back up your directory before you run this, because if it all goes really badly wrong, you might be better off going back to what you had. So just think about everything you run might go wrong, whether it's your fault or not. So always be thinking what your sort of backup plan is. Those we set earlier, 10 and 10, so that's fine. While log hints is off, don't worry about that. It's something you would turn on in production, but it won't be an issue for us. But it's telling you that if you need to rewind a primary that's, sorry, a secondary that's gone too far ahead, you need to rewind it back, then you will need that enabled, but we haven't, so never mind. The replication results will be created, which should be fine. Standby will attach to upstream node 1. That's what we want. That's one. That's the primary. So it's telling us that it's all going to work. So famous last words. We run exactly the same command, but this time we take off the dry run. And you can see here it's copied a ton of stuff over from the Barman server. I say a ton of stuff, it's only about 40 meg, so not that much of a ton of stuff. And it says you can now start your SQL server. Now we stopped it just earlier, didn't we? So if we just go up a few commands, oh, we weren't logged in as Postgres. Need to get out again to our sudo user and start it back up. And then what we'll do, just to kind of check, is we will tail. I don't know what the log is. Of course, it's going to tell us that. Right, so a few things to find. Those two lines are the most important. Consistent recovery state reached. Okay, so what happens is when you first start it up, this database is sort of like saying, oh, I'm not really in a very good state, but I've got all these log files, so I can recover, and it will automatically do that. It will go back to the nearest point in history that matches the log files. And in the case of this server, that will be right at the beginning of time, because we've never had a database here before. And then it will replay all of those log files and reach this consistent recovery state. It will then say, database system is ready to accept read-only connections, which is what we expect because this is a replica. Do not worry about this line. If you look, you start like panicking because you'll go, oh my goodness me, error, WoW file's not found, blah, blah, blah. All that's happening here is it knows that there is a log file, which is the latest log file, which is number 6, but that log file hasn't shipped yet. The reason it hasn't shipped is because it hasn't been finished by Postgres 1 server, so it's absolutely nothing to worry about. And if you connected to this with pgadmin or whatever, it would work absolutely fine. How do we know that? Well, again, if we log back in as Postgres, just to make it a little bit easier, just clear the screen. If we do psql -command and then select, I don't even know what the thing is, it's that, isn't it? Do that. Okay, so that is running on the local version of Postgres. So Postgres is up and running, it's fine, there's no error there, no problem with that. Let's quit out of that. So that was how easy the actual replication bit was. Now, since I've run that, this is now running live. So if I make a change on the primary, it will be reflected in the secondary. So this is running as a replica, but our work isn't finished. There's one more thing that we need to do, and that is we need to register this as part of the cluster. So it's all fine being a replica, doesn't have to be part of the cluster, but if it's not part of the cluster, when you use Repmgr to fail over, Repmgr isn't going to be able to tell this server to do anything. Maybe you don't care, maybe it's temporary, whatever, might not be an issue. But in our case, what we need to do is you need to do Repmgr standby, and again we can use -f if we're worried about it, and we're just going to register as a standby. Hold our breath. So what's it doing? Connected to local node Postgres 2, connected to primary database. It's saying that's not supplied, so it's assuming it's the primary. In most cases that's fine, so that's correct. But in the scenario where you have multiple primaries, which is possible, you'd need to tell it ideally which one's which. And then it says it's complete, successfully registered. So now what happens if we do a cluster show? We can now see we have 2 lines, which is fantastic. We have a standby node and a primary node. The star is the one that's actually active. Now what's confusing is you can have another primary. If that primary is unreachable and you promote Postgres 2, for example, to be a primary, it can show both as a primary, but the star will be the one that's actually the upstream node that's feeding all of the others. So you'll have one primary with a star and one primary without a star, yeah, it just means it's unreachable. In this case, the standby has to have an upstream, so that's where it's pointing to. Another thing you might not know is you don't have to just have a primary and loads of standbys. You can have a standby that is upstreaming another standby, which itself is upstreaming to the primary. So you can build chains of them. Obviously, all of that is extra latency, but it can reduce the load on your primary as well. So that's all we have to do. Obviously, I'm going to repeat that on Postgres 3, but I'm not going to put you through that because it's absolutely identical to what we just done on Postgres 2. And that's all working. Now, the last thing before we finish the video is just to remember, don't forget to document stuff. Now, you might be a company that uses automation, things like Ansible and Chef and Puppet and all that, which is amazing. If you do that, then that's fantastic because your documentation is in the scripts and it can go into source control and all that kind of shenanigans. However, there are lots of things there that are not going to run from Ansible. If you need to run a failover or even just trying to remember the commands to do a clone of a replica, it might not seem like that common a job, but I've been in a scenario where I've screwed up my failover and in the end decided to completely delete one of the replicas and create a new replica on it from scratch, just as a way to recover the cluster. Now, I don't want to be fishing around for documents when I've only got 2 out of my 3 replicas running, because that's when it's really asking for trouble. Because if something went down, you know, unexpectedly at that point in time, then I might be screwed. So having those things, document it however you want. We have wiki pages as well as Ansible, so I know how to do it the long format and also know how to do it with automation. But having those things just in one place where everyone knows where to get it, and you know, just be able to say, right, how do I create a new replica, how do I fail over, how do I fail back, and all the rest of it. So that's enough for this video. What we're going to do in the next video is we're actually going to look a bit more at the sort of high availability architecture and how we actually achieve high availability with our new Postgres cluster, including some of the failover options. So hopefully there's enough food for thought. Hopefully Repmgr is going to be nice and easy for you guys to set up. But otherwise, I shall see you in the next video.